Hello, everybody. Today, let's solve some absolute value inequalities with greater than or equal to 4. So, for example, let's solve the absolute value of x minus 10 closed absolute value greater than or equal to 4. Before we do that, let's get some ideas of what kinds of numbers that we can take absolute value of that'll be greater than or equal to 4. So, for example, let's start at negative 10. If I take negative 10 and then take the absolute value of that, it'll be 10. And is 10 greater than or equal to 4? Well, it certainly is. So if I had negative 10 inside the absolute value, then that will work. What about negative 9? Absolute value of negative 9 is 9. And is 9 greater than or equal to 4? Yes, it is. So negative 9 will work. So negative 10 will work. Negative 9 will work. How about negative 8? Yes, that'll work as well. Negative 7, negative 6, negative 5. How about negative 4? Let's try that one. Absolute value of negative 4 is 4. And is 4 greater than or equal to 4? It certainly is. And so negative 4 will work. So actually, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, and negative 4 are all such that the absolute value of each of those numbers is indeed greater than or equal to 4. How about negative 3? Absolute value of negative 3 is 3. And is 3 greater than or equal to 4? That would be false, right? And so negative 3 would not work. And likewise, negative 2 would not work, negative 1 would not work, 0 would not work, 1 would not work, 2 would not work, 3 would not work. Let's try 4. Absolute value 4 is 4, and 4 is indeed greater than or equal to 4. So 4 will work. How about 5? Make some space here. So 5, absolute value of 5 is 5. And is 5 greater than equal to 4? Is 5 greater than equal to 4? Yes, it certainly is. And so 5 will work. So all the numbers 4 and higher will work. So recapping, all the numbers less than or equal to negative 4 will work, and all the numbers greater than or equal to 4 will work. So this gives us some ideas of how to solve this inequality of absolute value of x minus 10, closed absolute value greater than or equal to 4. So this is how we do it. All right, so let me go back to the beginning now and write down this original inequality. Absolute value of x minus 10, closed absolute value greater than or equal to. So we said earlier that all the numbers that are less than or equal to negative 4 will work. And so in this case, we're going to take x minus 10 and make it be less than or equal to negative 4. So in general, what we do is if you have an absolute value greater than or equal to a positive number, then change the greater than or equal to a less than or equal to, and then change the sign of that number, in this case, 4 to a negative 4. So for example, if we had a 7 here, we would have less than or equal to, and then change the sign of the 7 to a negative 7. Likewise, if we had 134 here, then we would have less than or equal to, and then change the sign from 134 to a negative 134, whatever number I just said. So as a clear example, suppose you had 89, change the 89 to a negative 89. All right. And we're going to make two separate inequalities. So that's the first of two inequalities. And then we'll have x minus 10. And we said that all the numbers that are greater than or equal to 4 will work. So in general, just take x minus 10 in this case, greater than or equal to 4. All right, now we're going to get the x by itself. So we'll add 10 to both sides. X is less than or equal to 6. And over here, we'll add 10 to both sides. And x is greater than or equal to 14. Okay, so let's shade all these numbers on the number line. Okay, so since we have less than or equal to, we want to have a solid dot right here at the 6. And this is because it is true that 6 is less than or equal to 6. And we want all numbers that are less than that or to the left of that. And we want all the numbers that are bigger than or equal to 14. So 14 is certainly the lowest number in that case because it is true that 14 is greater than or equal to 14. And to be greater than, we have to be to the right of 14. All right, and then let's put this in interval notation. Let's use this graph that we just made here to put the answer in interval notation. All right, so we'll start at negative infinity, basically. And negative infinity always gets a parenthesis, and then comma 6. And since we want to include the 6, 6 gets a bracket. And then we're going to union this with the interval that goes from 14 on. And we want to include the 14, so put a bracket there, and then comma, and it goes onward forever to infinity, and infinity always gets a parenthesis. And so this is the full answer right here. So this represents all the numbers that are less than or equal to 6 inclusive and bigger than 14 inclusive. Okay, now let's do the same trick for this one. Okay, so since we have greater than or equal to 4, we'll take out the absolute value expression there. It's 10x, and we'll change it to a less than or equal to, and then change the sign from 4 to negative 4. And then we'll have 10x, and then it'll be greater than or equal to 4. All right. And now we'll get the x by itself. So divide both sides by 10. X is less than or equal to, and we can change this to negative 0.4. And then do the same thing here, divide both sides by 10. X is greater than or equal to 0.4. All right, and again, let's put this on the number line in order to help us get the interval notation format of the answer. Right, so we're similar as before. We have a dot there, and it'll be less than there. And then we'll have a dot right here, and then bigger than that. Okay, then to get interval notation, we always go from left to right. So going from left to right, it's going to be shaded forever in the negative infinity direction. So parentheses, the infinity, all the way until negative 0.4. And included, so it's a bracket, union, and then we'll include the 4 there, bracket, comma, infinity. And that's the answer right there. So that's how to solve an absolute value inequality that's greater than or equal to 4 in this case, or in general, any positive number.